if you want to tell quantitative representation of any chemical reaction, how can you tell? To that one, you have two ways. One is the how many number of particles participated and how many number of particles will formed in that chemical reaction. Another one is how much mass is involved in and how much mass will formed in that chemical reaction. These are the two ways to tell quantitative representation of a chemical reaction. To understand this one, you just take an example. Hydrogen reacting with oxygen, students, they will form water molecule. Okay, here two molecules of hydrogen reacting with one molecule of oxygen, they will form two molecules of water. This is the one way of representation. The another way is 4 units of or 4 atomic mass units of hydrogen reacting with 32 units of oxygen, and they will form 36 units of water, students. Okay, here among these two ways, which one is the convenient way to tell the quantitative representation? The first one is the convenient way to tell the quantitative representation of a chemical reaction. At this time, the concept mole was introduced by the scientist William Ostwald. See, 1 mole of anything. See, what do you mean by mole? Mole is nothing but it's a massive heap of atoms or particles. It's a large number. See, 1 mole of anything or any substance, nothing but maybe rice, maybe fruits or vegetables, or 1 mole atoms or 1 mole molecules or compounds or particles, anything which is having the number of particles are 6.022 into 10 power 23 particles are present in that 1 mole substance, students. Okay, this number also known as the Avogadro's constant or Avogadro's number, which is indicated with the letter N naught, capital N naught. Okay, this value coming from the experimental data only. Up to this extent, okay, it is the this number indicates how many particles are present in a substance, 1 mole substance. If you want to tell massive representation for 1 mole substance, nothing but what is the weight of 1 mole of any substance? How can you tell? To tell the massive representation of 1 mole of any substance, you have to take gram atomic mass or gram molecular mass. See, where we are getting these gram atomic mass or gram molecular mass, these values are coming from the relative atomic mass or relative molecular mass. See, how can you correlate these two values? Nothing but gram atomic mass and relative atomic mass, gram molecular mass and relative molecular mass. How can you correlate? Just take an example, students. Suppose you want to tell 1 mole oxygen atoms weight, how much you want to know. To that one, you can take first of all relative atomic mass of 1 oxygen atom is equal to 16 AMU, students. After that, I want to know the 1 mole oxygen atoms weight. I want to know. How can you calculate? To this one, you just do cross multiplication. Then you will get 16 AMU into 1 mole oxygen atoms. This is equal to the 1 oxygen atoms weight or 1 mole oxygen atoms weight, students. Okay, so you can substitute the values. What is the AMU value? 1.67 into 10 power minus 24 grams. And what is the 1 mole value? 1 mole value is the, we already know, 6.022 into 10 power 23, students. So that here you just simplify these values, 10 power minus 24 and 10 power 23. By cancelling this one, you will, the remainder is 1 by 10, students. Okay, And if you simplify 1.67 and 6.022 in 22, you will get only 10, and the remaining is 16 into 10 into 1 by 10 into gram also is the remainder. So 10 cancel, remaining value is the 16 grams. That is nothing but 1 mole of oxygen atom having 16 grams, students. Okay. At the same time, this 1 mole of oxygen having oxygen atoms having 6.022 into 10 power 23 atoms. Nothing but just simple one. 1 mole of anything having its molar mass, okay, and 1 mole of anything having Avogadro's number of particles. You just remember these two things, okay. See, this is the molar mass of oxygen, molar mass, capital M, okay, molar mass of oxygen, and this is the Avogadro's number of particles present in the 1 mole of oxygen.